Hello and welcome to this video. My name is Keshav Jadhav, and in this video we will see how to draw isometric view from given orthographic views. So question will be like this: draw isometric view from given orthographic views of object by first angle method of projection. So here orthographic views are given by first angle method of projection, means this will be the front view and this will be the top view. And we have to draw isometric view from this given orthographic views. So before drawing isometric view, we have to imagine and try to visualize the three-dimensional object for the given orthographic views. So we can see here in front view on left side there is a rectangle, and for this rectangle if we take the projection in the top view, there is another rectangle which is cut in half circle, and if you take the projection of this half circle in the front view, then there is dotted line for this, means there is a vertical rectangular block with a slot of half cylindrical shape. Now if we see here, there are four corners, 1, 2, 3 and 4, and for these four corners there are hidden lines in the top view, means there is slot of this shape and it is throughout its width, that is 50 mm. And if you see this inclined line, for this in the top view there is rib, so there is inclined rib of the width 10 mm. So in this way we have to imagine and try to visualize three-dimensional object for the given orthographic views. Now let us see step by step how to draw isometric view for this given orthographic views. So first we have to draw one horizontal line and take any point on that horizontal line. Then by using protractor, draw 30-degree inclination line on right side, then 30-degree inclination line on left side, and 90-degree inclination line, that is vertical line. So in given orthographic view, in front view here it is the point O, and in top view here it is the point O. So this point we have to take as the ground point. So this O point we have to take here in the isometric view. Now these are the XYZ axis called as isometric axis, and all the vertical and horizontal lines in the front view and in the top view will be parallel to any of these isometric axis, and those lines are called isometric lines. If any line or edge is not vertical or horizontal, means if it is inclined, then that line will not be parallel to any of these axes. So there is different procedure to draw such non-isometric lines. Also, you can see here this line, it is inclined at 45 degree to this horizontal line. So in isometric view we cannot take inclination as it is while drawing isometric view. So I will explain in detail how to draw such non-isometric lines in further slides. Before drawing isometric view, we have to draw the isometric box. So isometric box, it is not final object, it is just boundary of the isometric view. To draw isometric box, we have to check the maximum height and length in the front view and in the top view. So we can see here for the front view, maximum height is 50 and maximum length it is 100. So front view rectangle will be 50 by 100. And if you see in the top view, this length it is 100 and this width it is 50. So top view rectangle is 100 by 50. So to draw isometric box, we need three dimensions: length along x-axis, length along y-axis, and length along z-axis. This is the ground point O, and that point we have taken here, and we have to start with this point. So from O on right side, total length of this object is 100. So in isometric view, from point O on right side there is x-axis. So this 100 mm we have to take along x-axis. So we can measure 100 mm along x-axis and we can draw the line like this. Isometric box, it is not final object, so while drawing the lines for the isometric box, those lines will be the thin line or faint line. Now from O point in vertical direction there is 50 mm. So we can take this 50 mm along y-axis. So we can measure 50 mm along y-axis and we can draw a line. Now third dimension, it is along z-axis. So if you look at the object from the top direction, Then from O to right side, it is 100 mm length line. This line we have already drawn while drawing this front view line, which is along x-axis. Now from O to this side, that is left side, we have to take 50 mm length. In isometric view, on left side there is z-axis. So along z-axis we can measure the 50 mm and we can draw a line of 50 mm length. So in this way we have got three dimensions, that is along x-axis, y-axis and z-axis. So if front view is placed on right side of point O, then horizontal line will be along x-axis and vertical line will be along y-axis. Whereas if you see in the top view, if object is placed in right side of point O, then vertical line will be along z-axis. So in this way we will get three dimensions, and by using these three dimensions we can complete the isometric box. So in previous video I have explained how to complete this isometric box by using roll and draw. Now in this video I will explain how to complete this isometric box by using compass. So here we can take 100 mm length in the compass and draw a arc from this end like this. Then this height it is 50. So take 50 mm distance in compass and from this end draw intersecting arc like this. And then by using same distance from this end we can draw another arc. Now to complete this YZ plane we have to take this distance in the compass, and by using this center we have to draw the intersecting arc like this. Now we can join these lines like this. So similarly on this side there will be plane parallel to this XY plane, and on this side there will be plane parallel to this YZ plane. So by taking this much distance in the compass, take this as a center and draw arc on this side. Then by taking this much distance in the compass, that is 100 mm, and by taking this as center, draw intersecting arc like this. Similarly at bottom side also there will be one plane. Similarly at bottom side also we have to draw a line. So by using same distance in the compass and by taking this as a center, draw an arc. Then by taking this much distance in compass and this as a center, draw intersecting arc like this. Now connect the points by straight line like this. So this is the isometric box for given front view and top view. So we need only three dimensions, that is length along x-axis, length along y-axis and length along z-axis. So for this rectangular box there are total 12 lines. So to draw this isometric box, each length we have to use 4 times. Means along x-axis it is 100 mm, this is also 100 mm, this is also 100 mm and this is also 100 mm. So there are 4 100 mm length lines. Similarly along z-axis it is 50 mm. So this is 50 mm, this is 50 mm, this is also 50 mm and this is also 50 mm. Then this front view height it is also 50 mm. So this vertical it is 50 mm. So this is 1, this is 2, this is 3 and this is 4. So we need only 3 lengths, and each length we have to take 4 times to complete the isometric box. So let us draw lines one by one. So from point O on right side there is a horizontal line. So along x-axis we can draw this line. Now what is length of this line? Total length is 100 mm, and out of this it is 20 plus 30, 50. So length of this line will be 50. So from point O on right side we can measure the 50 mm and we can draw a line like this. Then we will draw this line. So this line it is 20 mm from this end. So from this end measure 20 mm distance and draw a line. Then we have to draw these inclined lines and this horizontal line. Now these inclined lines are non-isometric lines, so we cannot measure this angle as it is in isometric view. So to draw non-isometric lines we have to draw this shape separately with scale. So let us draw this shape separately with actual scale. So here this is the 20 mm, so we can measure 20 mm distance like this. Then let us draw this line. From this end we have to skip 30 mm distance and draw a line. Now here it is not required to draw this complete line, we need just this end. which are separated by 30 mm. So in this way we have taken this as 30 mm and this as a 20 mm. Now this horizontal line, it is at 10 mm from this end. So from this end we can measure 10 mm distance, and from this point we can draw a horizontal line. So we will draw a thin line at 10 mm distance like this. Now we have to draw this inclined line, which is inclined at 45 degree. So from this end we have to measure the 45 degree inclination. So by using this protractor, measure 45 degree inclination and draw a inclined line. Similarly, from this end on right side, measure 45 degree inclination and draw a line. So in this way we have drawn this part separately with actual scale. So we can make this line dark like this. Now while drawing isometric view of non-isometric lines, that is inclined lines, in isometric view we have to locate the end points by taking vertical and horizontal distance. So these ends we have already located here. Now we have to get this end and this end. So first we will draw this horizontal line, which is at 10 mm in vertical upward direction. So from this end we will measure 10 mm distance and we will draw line parallel to x-axis from this end like this. Now by using compass we can take this much distance in the compass, and from this end we can mark the point on this line. So we will get this end like this and connect these end points like this. Now to locate this end, again take compass and measure distance of this end from the same point. So by using same distance from this center, mark the point like this. Now we can draw this horizontal line like this. Now we have got this end and this end. So we can connect these two ends to get that non-isometric line. We can notice here these non-isometric lines are symmetric in orthographic view, but while drawing isometric view, these lines may not be symmetric. So in this way, first we have to draw non-isometric line with actual scale, and then by measuring vertical and horizontal distance, we can locate the end points and we can connect those end points to get non-isometric lines. Now let us draw this vertical line. Now from this end it is 20 mm. So from this end we can measure 20 mm distance and we can draw that line. Next we will draw this line. What is length of this line? This total is 100, and out of this 100, if we subtract 30, then length of this line will be 70 mm. So we will make a roll and draw parallel to x-axis, and from this end we will draw a line of length 70 mm like this. Then we will draw this vertical line and its length is 50 mm. So from O point along y-axis in vertical direction we can draw 50 mm length line. Then we can draw this horizontal line which is of 30 mm length. So from this end we can draw 30 mm along x-axis. So measure 30 mm length and draw a line of 30 mm length. Then we will draw this vertical line. So from this point along y-axis draw a vertical line which will connect these two ends like this. Now let us draw this line which is in the top view. So here from this end we have to draw this line. So this end it is here. So from this end we have to draw this 50 mm length line, means from this end. So make a roll and draw parallel to z axis, and from this end draw a line of 50 mm length like this. Let us draw this line. So from this end we can draw a line like this. Then these lines. Here total width it is 50 mm and radius of this semicircle it is 15 mm. So this total gap it is of 30 mm. So out of 50 this is 30 mm. So on this side it is 10 mm and on this side it is 10 mm. So from this corner we can measure 10 mm on this side and we can draw line. Similarly from this side also we can measure 10 mm and we can draw that line. Similarly at bottom side also we can draw 10 mm from this side, also we can draw 10 mm from this side like this. Then Similar to this line, on this side also we have to draw vertical line which is of 50 mm length. So make a roll and draw parallel to y-axis and connect these two ends like this. So similarly we can draw line at these two corners. Means it will connect these two ends as well as these two ends like this. Now we will draw this line. So this line, it is parallel to z-axis. So we can make roll and draw parallel to z-axis, and this corner it is here. So from this end we can draw a line parallel to z-axis, but only this portion will be visible, remaining portion will be hidden, and it is not required to draw dotted line in the isometric view. Similarly, we can draw this line. So this line, it is at this corner, means from this end. So already roll and draw is parallel to z-axis. So from this end we can draw a line of 50 mm length like this. Now to draw this rib, we have to first locate these 2 points. So this rib, it is of 10 mm width and it is at center. So here this total it is 50. So on this side it is 20 and on this side it is 20. So here we can measure the 20 mm from this side and 20 mm from this side, and we can locate these 2 points which are 10 mm apart. So on this side also we can locate the points. So from this end it is 20 and from this end also it is 20. So we will get those points, and this inclined rib is also non-isometric lines. So we will not measure this length as it is. We have just located the end points and we can connect those end points. So now we will draw this rib. So just connect these end points like this. So this is the rib. Now let us draw corner of this rib. So it will be parallel to x-axis. So from this end we can draw that corner like this. Now from this end also there is horizontal line which is parallel to x-axis. So from this end we can draw a line like this. Now we will draw the circular part. So radius of this circle, it is 15 mm and it is in top view. So we have to draw the circle in xz plane. So by using 4 center method we can draw that circular part. Now as diameter of this circular part it is 30, so we can make a rhombus of 30 by 30. This is 30. So from this point 15 mm on this side and 15 mm on this side, we can draw a line of 30 mm. Similarly on this side also 15 mm on this side and 15 mm on this side, we can draw 30 mm line, and we can complete the rhombus. To connect these points it will be parallel to z-axis, so we can draw line like this, and on this side also we can draw. So in this way we can complete the rhombus in the top view. Now we have to locate the midpoints of these lines. Length of the line of the rhombus, it is 30 mm. So we can locate the points at 15 mm, 15 mm. And for these sides already midpoint is available. Now this is the large angle and this is the small angle. So from large angle we have to connect the midpoints of the opposite sides. So this and this, it is the large angle. So from this large angle we have to connect the midpoint of this opposite points, means this point and this point. So let us draw lines from this large angle and connect the midpoint of the opposite sides like this. Similarly from this large angle connect the midpoint of this side and this side like this. Then this will be center C1, this will be center C2, this will be C3 and this will be C4. So in this way we will get 4 centers to draw the circular part in isometric view. Here we have to draw only half circle, so we need to use only 2 centers. So let us use center C1, and by using compass take this much as the radius and draw arc like this. Then by taking C3 as a center and radius is equal to this much and draw arc like this. So in this way we can draw this half circle. Now on this rectangular block there is half cylindrical slot, so there will be circular part at bottom side also. So instead of repeating 4 center method procedure at bottom side, we will just shift the centers. So we have drawn circular part at the top. Now we have to draw circular part at bottom. So this bottom circle, it is separated by 50 mm from this top circle. So we will just shift the centers by 50 mm in downward direction. So we will just shift the centers C1 and C3 in downward direction. So measure 50 mm distance in downward direction and shift the center C1 and center C3 by 50 mm in downward direction like this. Then in compass, take this much as the radius and C1 as center, draw arc like this. Now if you take C3 as center and if you try to draw the arc, then that arc will be at back side. So it is not required to draw that arc. Only this much arc is sufficient. So this is the complete isometric view for given orthographic views. Now we will give the dimensions. So this vertical it is 50, then this is 30. On this side, this is 20, this is 10, and this is the 50. Then we can give the radius of this circular part. So this radius it is 15, this width it is 10, 10, this is 100, this is 30, this is 20, then this height it is 10 and this also 10. This angle it is 45 degree. So in this way we can give the all dimensions. So this is the complete isometric view for given orthographic views. Now I have given link of the other videos related to engineering graphics in the description of this video. So you can go through those videos. Thank you.